Good night. At the moment we are going to review the next version of these videos, specific about the monitoring system to control, in next versions, the process or the fabrications of thin films, semiconductor thin films, by sputtering process. Okay. As we remember, the temperature to monitoring is in this chamber, as you can watch in front, here is front, is long here. Okay, in this chamber the pressure is like this in vacuum by the value 9 per 10 to 10 minus 7 millibars. Okay, a little review about sputtering process. We put a target here, for example, made by carbide silicon, and a substrate holder. Here there is a gas, specifically argon gas, by or into a magnetic field, which is in radio frequency. It can obtain ions of atoms of this gas, which bombarding these targets through the spread atoms to this substrate. Specifically, this is a little review of sputtering process, which happen into the chamber. But at the moment we don't have it is a device for measure this temperature of these substrates. And this system is going to do this work. This is the system. Now we are going to do a quickly review about that. But at the moment I want you to watch this. Okay, this behavior. White, please. I'm going to run the software, and we are going to watch the temperature. At the moment, the temperature simulated here is, and you can watch, just around 176.9. And you can watch noise, a little noise, but this is the behavior of the temperature by 300 samples. This is obtained by this educational acquisition card, and this is the simulating made by this heater. This garden heater. Okay, this was made by this design. We will going to put the thermocouple. This is the thermocouple. Next to the substrate. It's going to do into the chamber. The scale of this thermocouple is just around 44 microvolts per degrees Celsius. And this signal is going to pass to the 8595. This is the 8595. This is here. Okay. It can obtain a linearis and compensate this value, this scale, just around to this scale, to this new scale, 10 millivolts per degrees. Okay. Now this signal is going to pass to a buffer, to obtain the similar value, to avoid less value. For this reason, I put this buffer, and it's going to pass to a low pass filter. What was necessary this low pass filter? Okay. In last versions, if you remember, we obtained suddenly, for example, 23 degrees, and suddenly changed to 24, suddenly changed to 35, 36, or suddenly 16, 17, and it's not okay. Because the temperature couldn't change so quickly, and especially couldn't change as a random expression. It's not okay. For this reason, it's necessary to work with the low pass filter. The characteristic of this design was made about here, no, I decided working with this gain expressed in decibels. No, the past gain was minus 0.0035, and the reject gain was minus 30 decibels. This by these expressions, no, the gain not in decibels was made, but I choose 0.996 in input signal and output signal, and we obtain the gain. I decide this value, and the sample was made by 2 hertz, 2 samples per second, just around, and I decided to work it with, according to Nike's, 2 times this value, but more than this value, just around more than this value, for avoid the replics. No? Okay, and if you do this design, you can obtain this grades for this filter. Just around 4. No? For this reason, this is educational, because you can change this value. For example, 5 grades could be okay, or a 6 grade could be, if you improve this analyze here. No? Okay. This signal after pass to the microcontroller. Specifically, I working with the microcontroller 80 MHz. Okay, the signal at the moment is a logic value, and if you pass to the ADC, specifically into the microcontroller, this process, no, there is a software made here, no, and this value is going to change to the codificate value, to the digital value. No, I decided to work it to 10 bits as a resolution and 5 bits as a reference voltage. Given by this expression, voltage input respect voltage reference per 10 to elevate 10 as a resolution and obtain the expression. This is important because here is the information of the temperature, but now as a codification value. Okay, and this signal is going to travel to the personal computer. No? Specifically by the communication, no? I decided the serial RS232, no? Just around by this cable, just around 2 meters, because the chamber is long here, no? It's there, just around, as a distance is 10 or 12 meters. Okay, and the signal is going to come in here. No? We're going to monitoring, just for example, the signal of the temperature is just around here. It's increasing. We are going to increase this value. We are going to run the software and watch this value. Run software 5 and watch this value. We can watch this is increasing 143. This is increasing of the sample of temperatures. No? Okay, we are going to return here just a moment. Continue the explanation here. Okay, this is the cut. No? Okay. The software we are going to watch here is made by MATLAB. No? You can design it so simple software, not to work with the ADC high and ADC low of the ADC to expression this ADC as a value, just at temperature now. Respect the sample, no, of days which you are doing. Okay, this is the reference voltage. Respect the resolution, no, 10 resolution, and we can obtain the expression 5 millivoltage as an equivalent 0.5 degrees. No, remember this value, please. Okay, at the moment this is the explanations of this educational card. It could be made a good performance if you buy a data acquisition card. You can can find this in the market. Okay, but now you can design this. No, for practice your electronic and software design, and as was it make it here in this laboratory. Now we can watch, please, the temperature measure at the moment. We're going to watch. Run the software, please. Okay, and watch. It's just around 264.65. No? By the 35 samples. No? Okay, we are going to increase this value into the heater. This is a simulating, this is the maximum value. Okay, this is the maximum value. I made it on Saturday. It was just around 430 or 450. It depends on the position of this, of the thermocouple. Okay, we are going to measure again. This is not continuous because this is changing so quickly. No, if we let it here just around some seconds or some minutes, we obtain a temperature in equilibrium. Okay, but at the moment we are going to watch what is the temperature. We can watch. This is increasing. No, watch here, please. This is increasing the value. No, now it's just around 369.5. No, per 35 samples. That's okay. We are going to let here. No, I'll return here in just a moment. Okay. What is important? This analyze. Watch here, please. If we increase, specifically, if we change the temperature of the substrate, no, specifically, I'm going to work with a substrate holder, no, because it's the same temperature, just in the process. No? If we increase, maybe for a heater obtained by an electrical resistor, the heater obtained by this, not next to the chamber or into the chamber, and the behavior here is slightly the same that. No? And we can improve this behavior just as the controller PID. And why is important? Why is important have a controller here? Because if we change the temperature of this system, specifically of the substrate, we obtain, observe here, attention here, we obtain a new or chemical properties of this substrate, specifically of this thin film fabricated here. Also, if we change the temperature, we obtain change in the chemical property, and it could be made by that we can obtain this control by a software. It could be made in the next version, in the next version of this video. Now we can watch a new measure, please. Run the software. We can watch. Okay. Watch here, please. It's just around 389.3 around. Wow, this is a pretty behavior because it's also there is nothing of noise. No, for 35 samples. A new sample, please. Run the software and have the. Okay, we can watch here another sample, and this is with a little quantity of noise. It's happening because the temperature here is increasing. As you can watch here, it's increasing. Now it's 390.1. Okay, and the last run. Okay, watch here. Okay? Less noise, but this is the temperature at the moment. No? Okay. And finally, this is the educational data acquisition card, as we are designing here for this simulation, which is going to work into the chamber in next version, and specifically we are going to explain in next versions about the control of the temperature for obtain change in the chemical properties. Thank you so much for your attention. Bye.